Hello everyone, myself Nishandev from Sri Venkateswara College of Engineering. Today we are discussing about introduction to statistical modeling. Statistical modeling is a powerful tool for understanding and analyzing the data. It allows us to identify the pattern, relationship and trends that would be otherwise in handled with large data sets. Next, we are seeing the importance of statistical modeling. Statistical modeling are used across diverse fields from finance and healthcare to marketing and engineering. They provide a framework for making a data-driven decisions, predicting further outcomes, and gaining the insight in the complex phenomena. Next, informed decision making by uncovered ideal patterns. Statistical modeling helps us to make a better decision based on the data driven insights rather than guesswork. Predictive power. Statistical modeling allows us to forecast further trends and outcomes, helps us to plan and prevent for potential changes. Next, understanding the complex system, statistical model enables us to unravel the interactive relations with complex system, revealing underlying the machineries and driven forces. Next, we can see the types of statistical model. There are numerical types of statistical model, each designed for a specific purpose. Some common type includes linear regression, logical regression, time series analysis, and various model. Linear regression, predicting continuous outcomes variable based on one or more predictive variable. It assumes a linear relationship between the variables. Next, logistical registration predicts a binary outcomes based on the predicting variables. It uses a significant functions to model probability of outcomes. Next, time series analysis model data that change over time, identifying the trends, seasonality, and other pattern. It offer used to forecasting further values. Bayesian model. Based on Bayesian statistics, there are model income incorporates prior knowledge to update briefly about the parameters of model based on observation data. Next, we'll see the regression analysis. Regression analysis is a statistical technique used for in the relation between the dependent variable and one or more independent variable. This method allows us the qualification, the strength and directives of this relation. First one is simple linear regression, involves one independent variable and one dependent variable. Its aim is to best filtering state reference relationship between the variable. Multiple linear regression involves multiple independent variable and one dependent variable. It explores the combined effect to independent variable on dependent variable. Next, nonlinear regression used for the relation between the various nonlinear. It employ variable nonlinear with function to model relation between the variable. Next, hypothesis testing. Hypothesis testing in statistical model. Formulate hypothesis, state the num hypothesis and alternative hypothesis. Collect the data. Gather the data effect on hypothesis best tested. The data should be representative of the population. Calculate test statistic. Compute a test statistic that measures the descriptively between the observed data and null hypothesis. Next, determine p-value. Calculate the probability of an observation of the data and more extend a null hypothesis with the true. Next, make decision. Next, probability distribution. Probability distribution design a likelihood of defining outcomes in random phenomena. These are enhanced for the tools of understanding and qualifying the uncertainty in statistical modeling. In this, mainly normal distribution and binomial distribution and Poisson distribution. These three are mainly important. Next, model evaluation and validity. Once the statistical model develops, it evaluates in the performing, ensuring the variability. It involves the assessing how well the model fits data and ability to generate the unique accuracy. Measure the properties of currently classified instance in the classification test. Precision make the proper out to the true positive prediction out of the positive. Recall measure the proportional of the true positive prediction out of all accurate positive instances in the data. F1 scope. It's harmonic mean. Next, assumption and limitation of statistical modeling. Statistical modeling offer a array of specific assumptions about the data and relationship between the variable. Failures to meet their assumption can be led to accurate, inaccurate results and based conclusion. In this, linearity, independence, and normality and homoscalability. Next, application of statistical model. A statistical model finds a numerical application in different fields. First is in finance, healthcare, marketing, engineering, social service, and environment science. Next, conclusion and further consideration. For big data analysis, statistical model will plays a crucial role in analyzing the massive database and extract valuability. Machine learning, integrating of machine learning algorithm with statistical modeling which leads to more complex and predictive modeling. Next, artificial intelligence. Statistical modeling will be fundamental in developing intelligent system, learn, adapt, and decision based on artificial intelligence. Thank you for watching.